Eigrp load balancing. In this video, I'm going to talk about the feature of the load balancing in Eigrp. You know that load balancing is available in RIP, in OSPF, in ISIS, in BGP, okay? And this means that this is not a unique feature but for the Eigrp. But let me to explain one introduction about the load balancing, okay? And after that, you can understand that Eigrp has benefits about the load balancing with different routing protocols. Look at here. As you can see, here we have 5 paths from the router 1 to the, for example, 10700/24. Actually, these 5 paths, okay, are equal. This means that here we don't have any difference between the paths from the R1, R2 to R7, R1, R3 to R7, R1, R4 to R7, and also R1, R5 to R7, and R1, R6 to the R7. Actually, here we have 5 paths, okay, and these 5 paths, for example, have the same metric, okay. Actually, let me to write here R1, 2, R2, 2. For example, R7, this is the first path. You know that in topology table, we have all paths, okay? The next path is the R1, R3, and then R7. I will show you the topology table for this scenario. After that, R1, R7, R4, R7, and then again the R1, okay, R5, after that R7, and finally the last pass is the R1, R6, R7. You know that in topology table we have 5 paths, okay, with the same metric, exactly same metric. This means that when you are calculating the computed distance for all of these paths, the metric is same between all of these paths. Because of that, actually we can say that we have 5 successors, okay. Here in the topology table for the 10700/24, okay, we have 5 successors, and this means that we can inject all of these 5 successors into the routing table. And here in the routing, this is topology table, but in the routing table, okay, let me to show you what is happening in the routing table. We will have all of these 5 paths. For the 10700/24, we have learned from the Eigrp, okay, and here you can see that we have 5 paths. This is the load balancing or Eigrp load balancing. Another name of the load balancing is the equal cost multipassing. Equal cost multipass or ECNP means we have multiple paths with the same metric, okay, and after that we can load balance between them. It is so easy, and this means that, for example, assume that we are sending traffic from computer 1. The traffic from computer 1 may be sent from the R1 to the R2 to the R7, then to the C4 or computer 4, and then maybe the traffic of computer, for example, 1 with destination of computer 5 is passing from the router 3, router 7, router computer 5. Or assume that you are sending traffic from computer 1 to computer 6. The traffic is receiving by router 1, then router 4, then router 7, then C5. Actually, the traffic is load balancing, load sharing between these 5 paths. This is the equal cost multipass, means all paths are all paths have the same metric. Equal cost multipass is available in many protocols. Let me to write here ECNP, okay, ECNP supported in the RIP, okay, and then in the, for example, the OSPF, another routing protocol, in the Eigrp, okay, also in the ISIS, and also in BGP we have the equal cost multipass, okay. Let me talk about only the IGP protocols. In all IGP protocols we have the option of the ECNP or equal cost multipass. I will show you. But we have another type of load balancing, okay. Then the name of the next type of load balancing is UCLB. What is the UCLB? UCLB abbreviation of the unequal cost load balancing. Unequal cost load balancing or unequal load balancing means we can for example, load balance traffic between the paths with different type of different value of the metric. Let me to show you. Assume that here we are using in one of this link the bandwidth of the 1544 kilo. I will show you, don't worry about the detail. And also in this path we are using, for example, the bandwidth of the 1400 kilo, okay, means 1.4 megabit per second. Here we have 1200 kilo, okay, and here we have, for example, 1100 kilo, and here we have 1000 kilo, okay. As you can see now, we have different metrics between these 5 paths, okay. In Eigrp, with the feature of the Uclb or unequal cost load balancing, we can load balance traffic between these 5 paths, okay. This means that we can load balance traffic between different metrics, and this is only available in the Eigrp. Actually, in Eigrp, okay, we have the option of the unequal cost load balancing and also equal cost load balancing, but in other routing protocols we have only the option of the equal cost load balancing or equal cost multipass. The first thing that I'm going to show you is the equal cost load balancing or equal load balancing briefly, and then after that I'm going to talk about the unequal load balancing. You know that about the equal load balancing, this is supported in every routing protocol, every IGP routing protocol. But about the unequal cost load balancing or unequal load balancing, this is the feature this is the feature that is available only on the Eigrp. And now we can inform about one of the other benefits of the Eigrp to other IGPs. This benefit is supporting the unequal cost load balancing. Okay, let me to configure this scenario, and after that we can talk about some little difference or some little notes about the equal cost load balancing. Okay, the first thing that in this video we are experiencing is the equal cost load balancing or equal load balancing, and the second topic that I'm going to talk about that in this video is the unequal cost load balancing. The first is equal. Let me to start with the configuration of for example, one simple scenario, and in this simple scenario we are talking about the equal cost load balancing, means the load balancing between the past or multiple paths with the same metric. This is our simple scenario about the equal cost load balancing or ECNP in the Eigrp. As you can see, we have R1, R2, R3, R4, R5, R6, and R7, and also we have multiple paths with the same criteria, with the same attributes. And after that, we should configure first this scenario, and then we can experience and talk about the ECNP. You know that for IP addressing, we are using this formula Rx to Ry. This is the router y, X to router Y connected here. Between the router X and router Y, we are using 10.x.y0/24 network. This means that, for example, the interface of router X is 10xy.x/24, and the interface of router Y 10xy, okay, .y/24. You have learned about this method in previous videos. Okay, let me to start the configuration of R1. Okay, R1 en conft host name is the R1. We will use this scenario for two topics. The first is equal cost multipass. The second is unequal cost. For example, load balancing. Look at here. Then here, as you can see, we have 5 interface ETH00, and then we should assign IP address to this interface. IP address 10.121.255.255.255.0, and then no shut. And this is the interface ETH00 configuration. Let me to copy this configuration 4 times. Look at here. And then here, now we have ETH01, ETH02, ETH03, and finally ETH10. Okay, the IP address of the ETH01 is 10.131/24. The ETH02's IP address is the 10.141.255.255.255.0, and ETH03, this interface has the IP address of 10.151.255.255.0, and then ETH10 10.1, okay, 61. That's it. This is the configuration of the IP addressing in the router 1. Also, let me to configure the Eigrp you can configure EIGRP with the traditional method and also with the named method. In the router 1, I'm going to configure with the classic method. In the router 7, I will configure with the named method. Router EIGRP, okay, then 1, and after that you should use the network statement 10.1.2.1 quad 0. The first network statement. The second is network 10.1.3.1 again quad 0. The third is network 10.1.4.1, okay, quad 0. After that, network 10.1.5.1 quad 0. And finally, network 10.1.6.1 quad 0. This is the configuration of the router 1. So easy. Now let me to copy some part of this configuration for the router 2. Okay.